The session will be around 1 hour to 1 hour 15 minutes. So myself, GS Raman. My qualification is ME Computer Science and PhD. Submitted my PhD in the domain of big data and cloud computing. My PhD work is associated with cloud security. So I'm a corporate consultant and a trainer working on behalf of JPA Solutions Chennai, Bangalore. So for, these are all my proficiency, okay, in this technology. In terms of Oracle, I am an Oracle certified professional, OCP. I am a Sun certified system administrator. These are all my international certifications. In terms of Oracle, I am a OCP certified. And in terms of Solaris, I am a Sun certified system and network administration. And in terms of storage, I am a EMC square certified information storage professional. And in terms of cloud and big data, I am VMware certified cloud associate and VMware certified data center associate. Okay. And in terms of Amazon, I am an Amazon certified cloud architect. And for Hadoop, I am a Cloudera certified administrator. So these are all my international certifications. And apart from this, these are all my additional skill sets. In terms of the cloud, apart from this Amazon, I also aware of Microsoft Azure and OpenStack private cloud. And in terms of virtualization, so I am a certified professional for VMware. And in terms of big data, apart from Apache Hadoop, I also aware of this Apache Spark with Mesos, etc. And in terms of NoSQL database has been concerned, so I am a certified professional for MongoDB. So we taught MongoDB HBase and also Cassandra, and currently I'm doing training on this DevOps in association with this JPA Solutions. Okay, for GitHub, Maven, Chef, Puppet. So this is one of the most demanding thing with respect to a developer and administrator has been concerned in today's IT industry. So my association with the JPA is for the past 1.5 years. So I am taking care of the online training associated with JPA Solutions. Okay, so these are all my training and association with the JPA. So I had given training for employees of Wipro, Accenture, working with the Citibank Singapore. And we got training for Inatics Chennai, IBM Chennai, Wipro Qatar. So here and Wipro Infotech Bangalore. And here my current, then we have also given training for peoples of Wipro associated with the US and Australia. Currently, so if are in the last 4 months back, so on behalf of JPA Solutions, I had given a 3,000 days training program conducted in Singapore for Singtel, Singapore Government Telecommunication for Apache Spark and Big Data. So here these are all my current batches that I am handling. These batches, one batch for people's working with IBM, Accenture, Tech Mahindra belonging to Australia, US and New Zealand. Another one for our Indian guys. So working with Chennai, Bangalore, CTS, TCS. Okay. So one for big data scientist and another one big data Hadoop architect. These are all the current two batches, online batches currently that is going on. Okay. So in terms of apart from that, I used to give workshops in various engineering colleges, various technical IT corporates. These are to make them aware of what is virtualization, what is big data, what is cloud, what is DevOps like thing. So these are all the colleges associated in this for the past 1.5 year plus 2005, 16 and the first half of 17. Okay, PSNA, Anna University, KLM groups of institution, Lada Madhavan, RMK Group, Chennai, okay, Taradar College of Engineering, and then Dirajlal, Kammavar Naidu, Kamaraj College, SKR College, Journalism Engineering College, and RMK Chennai, RMD Chennai, Anand Institute Chennai, okay, Mahalingam Pulachi. These are all some of the renowned institute under which I had given a awareness program with 1 or 2 days or 3 days workshop like thing. So this is my competency with respect to this big data. So far in this mode, I had conducted around 100 plus training programs. Okay, and so far trained across 5,000 people working with engineering colleges, corporates, etc., etc. Okay, so this is my small introduction. So now we have an introduction about Mohammed sir. Abid sir, can you please let me know where you are currently working, and what is your requirement. Hello. Abid sir, you can now converse with me. Am I audible, Abid? Abid Merchant. You can talk with me now, please.
Hello.
Hello. Good evening.
Hello.
Hello, Abid. Yes, audible.
Actually, I am in third year engineering college in Vishwakarma, Ahmedabad, Gujarat.
Okay.
I want to pursue my career in big data. That's why I'm here to attend the session and know about big data.
Okay. Okay. You are currently with Gujarat, is it? Abid? Okay. Now we can start the session. So here in this first today's session is going to be for 1 hour session. In this session, the agenda for this session is as follows. Okay. So we are going to start with what is big data, why RDBMS can't able to use for storing what we called as big data. Okay, why RDBMS not? Then what is Hadoop? While discussing, we will have a discussion on how big data differs from the data that we are currently using in your RDBMS. Big data or Hadoop versus RDBMS. And I will finally let you know the Hadoop ecosystem, Hadoop architecture overview. The introduction to Hadoop architecture, Hadoop architecture overview of Hadoop, and Hadoop ecosystems. Okay, this is the agenda for today's session. Let me first start with what is big data. Okay, so here big data is a generic term. Big data is a generic term which is used to represent today's digital information. Okay, so big data means any data, any data instance. It may be a structured data, it may be a semi-structured data, it may be unstructured data. So which is beyond the storage and processing capability, which is beyond the storage and processing capability of a single centralized database server. Okay, this is the architecture currently followed by RDBMS, single centralized database server. That means you have data stored on only on a single server and on a single location only. Okay, the machine where you have your database has been termed as server. Okay, this is your database which contains data. So then possessing the following 4 key characteristics. So in terms of volume, the amount of data that is stored is termed as volume of data. Amount of data that is stored, that is minimum terabyte, petabyte, etc., etc. And the second characteristics, velocity, refers to the rate at which the data is generated. Rate of generation, speed of generation of data, rate at which data is generated. So yeah, big data is one which minimum it will generate terabytes of data per hour. And the important characteristics, variety. Variety refers to in terms of data has been in terms of data has been concerned, structured data, semi-structured data, unstructured data. Variety of the data. And fourth one, veracity. These are all the 4 key characteristics. Veracity refers to the reliability of your data, how far your data is reliable. Reliability of your data. So these are all the 4 characteristics which specifies you big data. Okay. So to be a layman point of view, a big data is what? Which is nothing but today's digital information. today's digital data. Okay, everywhere we have computerized, starting from a grocery shop, ending up with big shopping malls. We are making use of computers in today's world. So the amount of data that we are gathering is of a very huge in volume. So we need to store. If you take any applications, let me take social networking sites like Facebook. Per day, Facebook is generating 500 terabytes of data per day. If you take a Twitter per day it is generating around 200 terabytes of data. So if you take anything, if you are working with healthcare like thing, so healthcare today in India, so the amount of data that is generated by healthcare is around altogether 100 terabytes plus 100 terabytes per hour. Okay, that's much of data need to be stored, such as patient's record, patient's scan report, the patient's CT scan, ultra scan report like the per hour it is almost generating almost healthcare related 100 terabytes. If you are going with this banking, if you are going with these insurance sectors, everywhere at the average around 10-20 terabytes of data is generated by each and every banking corporate each and every day. Okay, so the amount of data that we need to store and process is in a huge volume in terms of terabytes. Okay, so here that is corresponding to volume of data. So here, what is big data? Big data is a generic term. It is a generic term which defines any data. Any data in sense it may be a structured data, semi-structured and structured data. Okay, if you take into consideration today's digital data, here only 20% of data comes under structured data and the remaining 80% of data coming under semi-structured or unstructured data. What is structured data? Your people are aware. You are worked with RDBMS like Oracle, a table, employee table with employee number, employee name, and salary like thing. Here the data will be organized in forms of rows and column format. You can store data employee number 1, employee name Ram, salary 9,000, employee number 2, employee name Anand, salary 10,000 like. Okay, so you can, if you want to access any particular value, if you want to access this Ram, you can specify this is first row and second column. Okay, here the data will be organized in form of rows and column format. This is the example of structured data. Today's RDBMS like Oracle, MySQL, SQL Server will follow this structured data. So what is semi-structured? Your PDFs, your documents, okay, emails. These are all examples of semi-structured data. Your XML file. They may have a structure, but they may have a partial. They may have a partial structure. Okay. So these are all examples of semi-structured data. What is unstructured data? The unstructured data, the example for unstructured data is your images, audios, videos. These are all example of unstructured data. Okay. So here, out of today's data, 80 percentage of data coming under semi-structured and unstructured. Only 20 percentage of data coming under structured data. Knowledge. Okay, so here the architecture currently followed by this RDBMS. So as of your knowledge, so what tool that we are using for storing data? We use RDBMS tools like Oracle, MySQL like thing. So these tool, the architecture of this RDBMS is single centralized database architecture. You have only one computer. The computer is designated as a server computer, and you have data stored in the computer. How a user can able to access the data? User can have interaction with this database through a computer called as client computer. Okay, the architecture is client server architecture. User will send a request to the client. The request will be taken to the server. It got processed, and the result will be again given back to the client. Okay, here the data storage and data processing both takes place in the server. The data storage and data processing both takes place only on the server. Okay, so what is the limitation in this case? If it is a single centralized database server, you can't able to store beyond this server capacity. Let me imagine the server contains 2 hard disks. Okay, so at a maximum, let me assume the server contains 2 hard disks with a each hard disk capacity of 2 TB. So how much of data that you can store? You can able to store only 4 terabytes of data. You can't able to store beyond that. Why so? Because யாரும் வரல அன்னைக்கு நீ கிளாஸ் இல்ல வேற பேட்ச் எடுத்துட்டு you can't able to store beyond 4 terabytes of data. Okay, so if you want to store 8 TB of data, can you able to store 8 TB of data here in a single server? You can't able to store. That is the problem associated with single centralized database server. Okay, so if you want to store 8 TB of data, what you need to do? So there is a solution. You want to go for a storage box. Okay, so you may heard about storage box. You have your server. Here we have a you have your server and you have a storage box. Like it may be a sandbox or it may be a NAS box, network attached storage or storage area network. You can store the data here. So whenever you need data, the data need to be bring into the server. Okay, that is the architecture that is supported if you want to store data beyond the server's hard disk capacity. So I think so you may heard about this sandbox and NAS box. Else if not else, I will let you know how it will look like. Okay, they are all used for storage purpose only. The box will be like this. These are all hard disk, housed with hard disk. Okay. This is your server in which your application is running, and this is your storage. Here your data will be stored. Okay. These are all hard disk. Hard disk 1, hard disk 2. Each and every one will have, these are all hard disk. Okay. According, imagine here this contain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hard disk. Okay, totally 3 racks. 13 into 3, let me make it to round up to 40 hard disk. Each hard disk capacity 2 TB means you can able to store 80 TB of data in this location. Okay, so this is called as a storage box. Okay, the storage box. But if you want to move the data from this box into the server where your application is running, it will be a time consuming. Imagine you have your film of 3 GB size. Okay, you have a current film, Bahubali film of 3 GB size. If you want to copy it in your pen drive, how much of duration that it will take? It comes around 4 to 5 minutes, roughly 4 to 5 minutes to copy a 3 to 4 GB of data in your pen drive. Imagine you have a 10 TB of data stored here. You want to transfer this 10 TB of data into a server means it is not at all possible. Yeah, 3 GB data, if it consumes 5 minutes instance, how much of time that is needed to transfer 10 TB of data? It need around 20-30 hours of time duration to transfer the data alone. Okay, so that is the problem associated with this architecture. If you want to use this sort of architecture, it is good if the amount of data that need to be stored and processed is in gigabytes. Nowadays in your big data, it is not in gigabytes, it is in petabyte. Okay, it is in terabyte. Minimum we need to take care of terabyte of storage. Okay, so it starts with terabyte, petabyte and so on. Therefore the architecture is not possible. So this is the drawback associated with single centralized database server architecture. Because of the reason you can't make use of today's infrastructure that is adapted by this relational database management system for storing what we called as big data. So that is the point 2. So data, any data which is beyond the storage and processing capability. Why we can't able to store? Why we can't able to process? Because of the huge volume of data. So because of the architecture, you can't able to store data beyond the server. It is not at all possible to store terabytes of data in a single server. So that is called as big data. And in terms of characteristics, in terms of amount of data that we need to store and process, it starts with a terabyte. These are all some of the real-time use cases which let you know how much of data that is generated in this thing and the rate at which the data has been generated. Okay, so that is called as velocity. So for example, if you take Facebook, Facebook is announcing a sale, yeah, reduction sale. Facebook, sorry, Flipkart, sorry, Flipkart is announcing a 30 to 40% of reduction sale. Okay, so here initially this is your Flipkart. Assume that this is your Flipkart web server. The sale starts with 10 a.m. and end with 1 p.m. Okay, so 1 p.m. So 3 hours sale. So normal days in Flipkart, let me imagine 1 lakh of people at a time visit across the world to Flipkart web server to purchase things. Okay, during the sale period, what happens? In the beginning of the sale, 10 a.m., you have 5 lakhs of people being the sale is beginning at 10 a.m. Or let me imagine 5 lakhs of people approaches web server. As time is going on, 10:30, 11, what happened? The number of people go on increasing, 10 lakhs, 15 lakhs like thing. Okay, so this is the volume of data that is approaching to the server. This is called as velocity. Velocity refers to the rate at which the server need to handle that incoming request. If it is RDBMS, okay, so here in this case, how much of data will approach the server? Per hour around terabytes of data. For example, if you take Facebook 1 day it is generating 500 terabytes 1 day. At the average, if you take 1 hour, it generates 25 terabytes of data. That is referred to as velocity, the rate at which the data is generated. Okay, so if it is a single centralized server, if the data is coming in this speed, the server can't able to tackle this much of volume of data. So that is the second characteristics. And you know the third characteristics is variety. It refers to the different types of data. So here let me make a difference between RDBMS and what we called as big data. First one, in terms of volume, RDBMS support up to gigabytes and up to 1 or 2 terabytes. Okay, if it is a minimum amount of terabytes, you can on to let me make it up to 10 terabytes of data. Okay, 10 terabytes of data it can support. Whereas big data starts with minimum terabyte, zettabyte, petabyte, etc., etc. Okay, that is the first difference. Velocity, the rate at which the data is approaching to the server. If it is gigabytes per hour, then RDBMS can able to tackle that workload. Whereas big data is one in which the data generation speed is terabyte per hour. A minimum speed is terabyte per hour. The third characteristics, variety. So RDBMS support only structured data. It does not support a semi-structured and structured data. A big data is one which has structured data, semi-structured data and unstructured data. You already aware what is semi-structured and unstructured. And in terms of veracity has been concerned, here veracity refers to how far your data is reliable. In RDBMS, you need to input only a clean data, a pre-processed data. So the data should not contain any inconsistencies. Data inconsistencies should be avoided. Data should not contain any null values. Okay, null value should not be. The data should adhere to the schemas data type. For example, if you have specified employee number as integer, you can insert 1 or 2. You can't able to insert A1. Also because A1 corresponds to varchar, which is against the employee number data type. So the data should adhere to the schema. It should not contain inconsistency. It should not contain missing value, not null value. It should not contain any value unfilled. So these sort of anomalies need to be overcome, and then only you can able to store the data in RDBMS. Whereas in big data, the data sources may be a human generated data, or it may be a machine generated data. Like if you want to crawl data from RFID, you can crawl data from IoT, Internet of Things devices like sensors. You want to crawl data from sensors, RFID tags like thing. So human generated data, machine generated data. Being you can get the data from these social networking sites such as Facebook, Twitter, etc. So being these data are generated, crawled in a live environment, you can't able to ensure inconsistency or missing value should not be present in those data. These data may suffer from the above said anomalies, but the tool which you used for storing and process the data should have inbuilt capability of tackling this thing. That is called as veracity of the data. So, based upon these four characteristics, we can differentiate what is big data and how it differs from RDBMS. Okay, RDBMS stands for Relational Database Management System. The tool used for is Oracle, SQL Server. Similarly, big data is a generic term. Here the tool used for is Hadoop. Hadoop is a tool. We call this tool as a framework for storing and processing what we call as big data. Okay, I'm making sense. Do you have any doubt? This is the generic definition for big data. Now, in terms of apart from this, in terms of architecture has been concerned. Okay, so here in terms of before going into this architecture, let me discuss what is Hadoop. Okay, Hadoop is a tool. Generally, we call it a tool, which is nothing but a framework, a component of constituent of several subtools, which is used for storing and processing what we call as big data. Similar to that of Oracle, MySQL, SQL Server. Here, Hadoop is a tool which is a combination of several subtools, which is used for storing and processing what we call as big data. Okay. So here, who developed Hadoop? So Hadoop was developed by the Apache open source community. Apache open source community, which is a open source software. Okay. So Hadoop was developed using Java programming language. It was written using a Java programming language. Okay. So why you need Hadoop? Being your RDBMS tool. The architecture of RDBMS is single centralized architecture. You can't able to store data beyond this server. So we consider today's digital information. We need to store terabyte and petabyte of information, which is generating at a minimum speed of terabyte per hour, and whose variety is we need to store structured data, semi-structured and unstructured data. Being the data source or real world entities, it may suffer from several anomalies like inconsistency, missing value like thing. To tackle all those sort of anomalies, this server, that is the architecture currently adopted by RDBMS, a single centralized architecture, we can't make use of to accommodate all the above set characteristics data. Therefore, we need a tool. Okay, that we need a tool which is not supported by RDBMS. So we got a solution by name data appliances. Okay, so we got a solution by name data appliances. So data appliance is nothing but the hardware combined with a specialized software, a sophisticated hardware with this customized software. So examples of data appliances are Teradata, Exadata, Netisa, Green Plum. Okay, I will show you. Let me take Teradata in our Google. They are sophisticated hardware with the customized software used for storing and processing what we call as big data. Teradata. Okay, this is by Oracle. They are all higher end servers. Let me take this. They are all higher end servers. Okay, you can find the server with the model 560 can store up to 12 terabyte of data. So which is used for storing and processing huge volume. You can find another server which can accommodate 186 petabyte, here 343 petabyte. So it is a combination of several servers which is used for storing and processing what we call as big data. Okay, so it provides very huge computing and storage capacity. So these are all some of the examples of data appliances. Okay, if you go another example, what I have let you know, Teradata. So here there is Exadata. It was by Oracle Corporation. You can find these higher end servers. They are all higher end sophisticated servers, which is specifically designed for this purpose. Okay, so with high RAM capacity and high large number of cores. Okay, terabyte of RAM. You just look into 14 terabyte of RAM. Okay, 240 terabyte of storage disk with multiple core computers. Okay, these are all some of the so database in memory machine, so data warehouse machine in which the software which is used by this machine is especially designed for handling what we called as big data. Okay, these are all some of the examples of data appliances. So here why you need data appliances for storing data that we have categorized under big data. Why we need data appliances? Being your RDBMS couldn't able to accommodate what we call as big data, we need another solution. The solution arrives in form of data appliances. Then even if we have a solution by name data appliances, what is the necessity in going for Hadoop? Okay, Hadoop is again a framework. The advantage of going for Hadoop compared to that of data appliances is data appliances is made up of sophisticated hardware with some customized software. Here the cost involved is very high. This hardware server, this server will cost around crores, minimum 5 crores if you want to get a good server. And the software cost is also a licensed software. You need to pay according to the volume of data that you are storing. So these are all the drawbacks associated with these data appliances. So imagine a company, a country like developing country like India. Out of 100 companies in India, around 70-75% of companies are small medium level companies or enterprise level companies. So is it possible for those companies to invest 5 crores to establish the infrastructure? Not at all possible. They have only the initial investment around 1 or 2 crore. But if they want to invest for storing and processing 5 crores means it is not at all possible, not affordable for this company. Very big enterprise level companies like Reliance, Megamart like thing, it is possible for them to invest that much of amount for the infrastructure. But nearly 70-75% of companies in developing countries like India is coming under mid-level or medium or small level company. It is not at all possible, but they have the data of the big data caliber. They need an environment for storing and processing in a effective and a cost effective manner. Here comes a solution from the open source community, Apache open source community. They developed a framework called as Hadoop. Okay, the Hadoop, the advantage of going for this Hadoop, I will let you know. Document எங்கே வச்சிருக்கோம்? Okay, please wait. I will share you with some document பார்த்துட்டு. Okay, so now Hadoop is a open source project developed by Apache Software Foundation. Okay, Hadoop is written using Java programming languages. It is used for storing structured data, semi-structured data, and unstructured data. So, by the important advantage here, you can able to store the data using inexpensive commodity hardware. What is commodity hardware? You can make use of a low cost hardware. As of your data appliances, you no need to go for a higher end servers for which you need to invest minimum crores. So you can make use of i3 computer, i5 computer, i7 computer. Okay, very low cost hardware. And more importantly, in terms of softwares, all the software that we are going to use associated with this Hadoop are open source softwares. Open source, free softwares. We no need to pay anything for this software. Okay, all are open source. Whereas here, the solution that we used before Hadoop is data appliances. Here the drawback is hardware. You need to invest in terms of crores, and all the softwares are paid software. It is not a open source. They are all licensed softwares. So here everything has been resolved in terms of cost. So it is highly cost effective. Okay. So here Hadoop is not meant for OLTP. It is not for online transaction processing. Okay. Such as your transaction processing systems currently used with RDBMS. It is meant for OLAP. Okay, it is good for OLAP and DSS. OLAP stands for Online Analytical Processing. DSS stands for Decision Support System. You have data stored. Those data may have some inherent informations. Okay, some informations might have been hidden into those data. If you look into the data, it won't be revealed. You want to apply some algorithms, you want to apply some logic on top of the data to dig deep into the data to explore those hidden informations. So those informations may contain enough data, enough information by using which you can able to enhance your business. Okay, so this sort of thing is called as analytical processing, online analytical processing. Okay, it will help the business to tackle in case if a business is in loss, to identify the root cause behind loss, to identify the loopholes in your business. What you need to have a data, somewhat around 10 years of data. Okay, by going through this data, you can identify the loopholes, and once the loophole has been identified, you can resolve the loopholes and you can make the business to run in a successful manner. So for this purpose, we go for this big data. Okay, the Apache Hadoop. That is the reason why it is mentioned as it is for OLAP, not for OLTP. Okay. Now you have Hadoop 2.x, 3.x can be used for OLTP also. That I will let you know. So this is some of the basic descriptions will let you know what is Hadoop. Okay, Hadoop is a framework. So with respect to this architecture, now you know what is RDBMS, what is the drawback associated with RDBMS, and you know the solution in form of data appliances. You also know the drawback associated. Now what is the solution? Now Hadoop, what are all the key characteristics of Hadoop? Also you know what is big data and what are all the key characteristics of big data, how it differs from traditional RDBMS. Okay. So now we are going to discuss about the architecture of this Hadoop. Okay. So the Hadoop and RDBMS. You know RDBMS is a single centralized database server. Here we have a distributed database server. You have distributed database server. That is the first difference. The second one, in terms of the infrastructure architecture has been concerned, it is a client server model. It is a master slave model. Okay, here you have data stored only on a single server. Imagine if you want to store 10 TB of data, then the server should have a capacity to accommodate this 10 TB of data. Okay, so here your data is not stored on a single machine. Your data will be splitted and it will be distributed across multiple machines. For example, imagine each machine with the 2 TB hard disk. If you want to store this 10 TB of data, how it will be stored? 10 TB of data is splitted into 2 TB each, and it will be distributed across all the computer. The computer where we store the data is called as data nodes. We have 5 data nodes. Whereas in case of this RDBMS, you can't able to extend your data beyond this single computer. Whereas here you have 10 TB of data, and using 5 data nodes you can able to store the data. If your data size increases to 20 TB, you no need to bother about. You can go and add further 5 data nodes. Now you have 10 data nodes. So by the way, if your data size increases, you no need to bother about the infrastructure. You can go on add your data nodes. That is the advantage of going for distributed database. And in terms of architecture, you know you have only one computer called a server where you have the data, and you have user will have interaction to this database through multiple clients. You may have client 1, client 2, up to n client. Through this client only, user will send a request. The request will be transferred to the server where it got processed, and the result will be returned back to the client. So this is the architecture where data storage and process will take place. The data storage and data processing will take place only on the server. Data storage and data processing takes place only on the server. Whereas in this case of architecture, it's a master slave architecture. We have some computer designated as a master computer, such as we have a computer called as a name node, and we have a computer called as a secondary name node. We have another computer called as a job tracker. We need to configure these computers, and we have data nodes. And our slave, we have data nodes, and we have task tracker. So here this group of computers together called as, you have a computer called a name node, you have a computer called a secondary name node, you have a computer called job tracker, and you may have multiple computers called data nodes. Data node 1, you may have n data nodes. Data node 1 up to n data nodes. Okay, this computer togetherly, a group of computer togetherly called as Hadoop clusters. Cluster is nothing but a group of computers. Out of this group, the topmost 3 computer comes under the master category, the bottom computer comes under the slaves category. Okay, each and every computer will do certain functions. Here the data storage and data processing takes place only on the data nodes. We will store the data and we will process the data only on the data nodes under the supervision of the master nodes. The name node, the secondary name node, and job tracker node won't store the data. It won't process the data, but it will control the storage of data and it will control the process of the data. Once our session have been progressed further, we will have a discussion on the associated functions of node. Just for this moment, you imagine that these are all computers that you need to configure in your Hadoop cluster. Okay, you want to configure this much of computer. So how many name nodes? You need to configure only one name node, only one secondary name node, only one job tracker. You may have n data nodes. The number of data nodes is n in number. N depends upon 2 factors. One, okay, in your Hadoop cluster, you cannot have more than one name node or more than one job tracker, but you need to have multiple data nodes. Which factor will determine how many data nodes? There are 2 factors. One is the volume of data that you need to store. Example, in this case, if I have 10 TB of data, imagine. The second factor is the hard disk capacity of your data nodes. In this case, imagine you have 2 TB hard disk capacity. The data nodes hard disk capacity is 2 TB. Okay, these are all the assumptions. With this factor, how many data nodes you need? 5 data nodes. With the assumption that you have only one copy. But in Hadoop, we need to maintain 3 copy. Therefore, 5 into 3, we need 15 data nodes. If the data node size is 2 TB, to store 10 TB of data. Okay. So, if you want to store 20 TB of data, in this case, you need to have how many data nodes? 30 data nodes. Therefore, the number of data nodes depends upon these 2 factors. Okay. Here, in terms of this Hadoop job role has been concerned, you have multiple job roles. You have the following 3 job
Getting here.
roles. Yes?
Hello?
Any
Yeah,
doubt?
actually I'm not getting how it's working.
Hello?
Can you come again the topic that how the data node designing?
Oh, how the data nodes are designing. Okay, no issue. So here Hadoop is here in your cluster you can't have beyond one name node. Your cluster can contain only one name node, only one secondary name node, and only one job tracker. Now you can have multiple data nodes. The number of data nodes, you can have n number of data nodes in your cluster. Data node 1, data node 2, up to n. Which factor will decide how many data nodes that you need to have? Two factors will decide this. So first one, how much of data that you need to store. That is the volume of data that you need to store. How much of data you need to store. That is the first factor. Okay, it represents the volume of the data. The second factor is the HDD stands for hard disk capacity of your data nodes. What is the hard disk capacity of your data nodes? For example, I am having 10 TB of data. Okay, the data size is 10 TB. I want to store 10 TB of data. My hard disk capacity of my data node is 2 TB. So to accommodate this 10 TB of data with a data node with the capacity of 2 TB, you have data node 1 with 2 TB storage. How many data node that you need? 10 TB divided by 2 corresponds to you need to have 5 data nodes. Okay, data node 1, data node 2, up to you need to have 5 data nodes. Yes, here the data 10 TB in your Hadoop, so will be stored in forms of blocks. That we make it in forms of blocks. For example, imagine a small file 192 MB size. So here the default block size is 64 MB in your Hadoop. This 192 MB, yes, let me make it is a file 1.txt, which whose size is 192 MB divided into 3 blocks, block B1, B2 and B3. So each block size is 64 MB. So here each block will be replicated at 3 locations. We have 3 replica. That means each block need to be stored in these data nodes at 3 locations. Block B1. 3 copies of blocks need to be stored. Why so? Because so if you have only one copy in your data node 1, if your data node 1 get crashed, what happens in this case? If you have only one copy, you will lose your data. Being the data node is made up of commodity hardware, which is of low cost hardware, you can't able to predict at what time the commodity hardware will fail. So because of the reason, it is recommended that so to ensure the high availability of your data, to prevent your data loss, Hadoop instructs you to make minimum 3 copies of your data. Okay, so the data need to be stored across minimum 3 data nodes, so that if one particular data node fails, still you have true copy which is distributed across the remaining 2 data nodes, so you can able to perform a read or write activity from those data nodes. That is what I let you know. So imagine you have 10 TB means if you want to maintain 3 copies, how many TB that you need to store? 30 TB that you need to store. Imagine if your data node size is 2 TB means then you need 15 data nodes. That is what that I had explained. Is it clear now?
Yeah, yeah, it's fine.
Okay, so to store 20 TB of data means if into 3 copies means you need to accommodate 60 terabyte. So if your data node size is 2 TB, in this case 30 data nodes will be needed. So that is the thing which these two factors will determine how many data nodes that need to be accommodated in your Hadoop cluster. Okay, so here the task tracker we have designed. Okay, in our slave we have data node and task tracker. A task tracker, if we have 5 data nodes, then we have 5 task tracker. Data node, if we have 5 data nodes, we have 5 data task tracker. A task tracker is nothing but a process running on the data node, a background process running on the data node. Remaining things are physical servers. The name node, secondary name node, job tracker, and data nodes are physical computers. Whereas the task tracker is not a computer, which is a background process running on the each and every data node. Okay, whose responsibility is to run a task. Now, in terms of this Hadoop job openings has been concerned, there is administrator, Hadoop admin, Hadoop developer, Hadoop analyst or data scientist, and you have a Hadoop tester. These are all the 4 roles. Okay, what is the role of administrator? To establish this cluster. As I told, you need to establish a cluster with the name node, secondary name node, job tracker. You want to configure multiple data nodes. You want to maintain and you want to manage those clusters. That is the role played by the administrator. People working as a Linux admin, people working as a Unix admin, people currently working as a DBS like Oracle DBS, SQL Server DBA, and people with this data warehousing stuff. People in more specifically in foreign countries, people worked with the mainframe. They are now looking for the Hadoop admin related openings. Okay, so you should have a Linux knowledge to make it as a Hadoop opener, Hadoop admin. So you have data stored in this. So to process the data, we need to write some programs. So that is the role played. The program that we want to write here is MapReduce program. You want to follow a architecture called MapReduce programming model. Using this programming model only, you can able to access the data stored in your Hadoop. So the developer's responsibility is to write the program. Then the analyst or data scientist, DS, you have data stored. Okay, using this data, you can predict what happens in the future. Predict. Okay, so the data may have some inherently hidden informations. Using some algorithms, using some machine learning algorithms, using some data mining algorithms, you can dig deep into the data to expose you what information, what knowledgeable patterns has been hidden into those data, and using those information you can able to predict the future. That is the role of analyst. Okay, the administrator need to establish the cluster. If you want to write a business logic, you need to write a program. That the program need to be written by the developer. The programming model used here is MapReduce programming model, and those data which is gathered in Hadoop may have some inherently knowledgeable patterns hidden. To explore those patterns, we need a data scientist. And the tester role is similar to test performance related test and bug related, code related bugs. We have a tester. Okay. So the developer, those people who are already working as a Java developer, .NET developer, Python developer can opt for developer role. SQL developer. An analyst, what you need an idea on data mining, data warehousing, you need an idea on statistics. So they can go for analyst role. Tester, with the testing background, with if you have aware with J, you need the Selenium like a testing background, you can go for a tester role. It is your choice. According to your basic stuff that you are in possession, you may opt for accordingly. Okay. So this is the way by which data which is stored in a distributed database cluster like Hadoop can able to overcome the difficulties that we have faced in terms of RDBMS and data appliances with a very low cost in terms of hardware and almost nil cost in terms of your software. Okay, so with this part, now we are going to discuss about the final part. So as I told, Hadoop is a
Here
framework.
I need
Yes.
actually. This is that map reduce program actually. This is a simple Java program or it is some different kind of Hadoop.
Yes, I am letting you know now those things. Okay, so you have data stored here in your data nodes. You got data stored in your data nodes. Data node 1, data node 2. In data nodes, here the file system used is HDFS, Hadoop Distributed File System. If you want to do any process on top of it, you need to go for a model called as MapReduce programming model. You can make use of Java, you can make use of Perl, you can make use of Python, you can make use of Ruby, etc. to write this MapReduce program. Okay, so it is a normal Java-like program, but it involves some additional concepts. Here you have to write a map. The input is given to this map function, which is subjected to the following transformation: shuffling, sorting, combiner, partitioner, and finally those output is fed as input to the reduce function. From the reduce function you will get a final output. Okay, so this is the sequence of activity that you need to perform in a MapReduce. Here a developer's role is to write a business logic in map function and reduce function. The remaining thing will be taken care by the Hadoop framework itself. Okay, if you are aware of this programming language, you can go for. If not, else. Here, Hadoop provides us two tools. One is Hive and another one is Pig. Okay, Hive was initially developed by Facebook. Pig was initially developed by Yahoo. Hive uses a language called as HiveQL. Pig uses a language called as Pig Latin. The user, these two things is almost similar to structured query language. You no need to break your head in writing a complex instructions. If you go for this native programming language like Java, Python, you can very simple technique like SQL. Writing a query in SQL is very simple compared to that of writing the same thing in your Java. So here it uses a Hive query language. It is almost 95% is similar to SQL and Pig Latin. Then Hive will internally transforms the query into MapReduce, which is transparent to the end user. The advantage of going for Hive and Pig than Java is for your business logic. If you want to write a program which runs into 150 lines of coding in Java, the same program if you have written using an Hive and Pig, which can be completed between 10 to 15 lines. Such a powerful tool which is incorporated with several built-in functions. Okay, so almost in industry 90 to 95 percentage of all business logic will be written using Hive and Pig. Only some 5 percentage of logic, if you want to customize a certain thing. Okay, for example, you in these circumstances you want to write a user defined function, we call it as a UDF. If you want to do some customized task, then in this case you want to write a UDF, user defined function, and that circumstances will be only 5 percentage out of your requirement. Only 5 percentage it may need to write a UDF. For that you can make use of the above said language. Remaining 95 percentage of activity you can able to make it using Hive and Pig. The advantage of using Hive and Pig is that in terms of the number of lines of coding has been concerned, it is very less in number. Okay, also it is very easy for the developer to write the business logic rather than going for a complex logic incorporation if you go for a programming language like Java. So here now we have another framework called as Spark. Okay, Apache Spark. Since Apache Spark is not a replacement to Hadoop, it is a replacement to the MapReduce. Okay, so we call the Spark as a in-memory data processing framework. In-memory data processing framework. The advantage of Spark is it stores intermediate data in the RAM memory. While doing some process, a MapReduce process, the intermediate data will be stored in the RAM memory. All the read and write will take place only in the RAM. Whereas MapReduce, all the read and write intermediate data will be placed in the hard disk. Because of the reason, reading and writing the data from hard disk will be a time consuming compared to that of reading and writing the data from the RAM memory. So because of the reason, Apache Spark now is almost said to be 100 times faster than the MapReduce. That is because of the reason each and every corporation now they are looking for going for a Apache Spark. Okay, so these are all some of the way by which you can write a program using either a native programming language or using this tools coming integrated with this Hadoop called Hive-P. Okay, so apart from that, we have some data crawling tools. You have data stored at different data sources. Those sources may be RDBMS. You may have a server. Okay, you may have a web server. You may have a database server or mail server. Okay, so these are all RDBMS databases. From these databases, you need to bring the data into your HDFS. For that, you make use of a tool called as Scoop. So if you have data stored in Facebook, you have data stored in LinkedIn, you have data stored in Twitter. They are all either unstructured data or a semi-structured data. Data which is stored in your RDBMS are called structured data. For crawling those data, you need to use Scoop. If you want to store a semi-structured, unstructured data like mail or Facebook data from Facebook, Twitter, or data from some sensors, then you need to use of a tool called as Flume. If you are want to crawl a streaming data, you want to make use of a tool called as Kafka. They are all data crawlers, data ingestion tools. Okay, so you have data ingestion tools, you have data processing tools, and you have storage. HDFS is a storage. Else you can go for a database like a HBase. You can go for a database like MongoDB. You can go for a database like Cassandra. There are hundreds and hundreds of databases. Okay, they are all databases used for storing, and they are all processing tools. And we have another tool called as Uzi, which serves as a automatic task scheduler. Okay, and we have another tool called as Zookeeper, which is used to coordinate all the tasks. We have Zookeeper, and we have a tool called Ambari. You can add it on top of it. It provides us a graphical user interface of interacting with this Hadoop cluster. We have Ambari. We have a tool like Hue. We have tools like Cloudera Manager. If you go for distributions like Cloudera and Hortonworks. Okay, here we have some concept called as Hadoop distributions. We have some concept called as Hadoop distribution. So here, what is you have a Linux. Linux is a open source. From the Linux, you can download the source code and you can write some new features on top of it. And it was released as a Red Hat Linux, and it was released as a Ubuntu Linux. You have CentOS like hundreds of Linux. Similarly, you have this Hadoop, which was developed by Apache Corporation. They gave it as an open source, so you can able to download the source code and you can add new features on top of it and you can release it under your own name. Here, similar to that, you have a release called as Cloudera Hadoop distribution. Okay, CDH, and you have Hortonworks, HDP, and you have Mapr, and you have Big Insights, and you have EMR, Elastic MapReduce. They are called distributions. 80 to 85% all distributions are similar to this open source Hadoop, and Cloudera may add some new features on top of it to facilitate the easy user interaction. The feature used by Cloudera is Cloudera Manager, and the Hortonworks may make use of a feature called Hue, and the Mapr. Big Insights is a distribution by IBM. EMR is a distribution by Amazon. So these are all called distributions. Out of these distributions, today's world market, nearly 70 to 80% of world market is with the following two distributions. Okay, so these are all some of the way by which you can go for implementing a Hadoop cluster according to your requirement. Okay, so with this information, it is time to wind up today's session. Being it is introductory session, I want to let you know a bird's overview of what is Hadoop, what is big data, how it differs from RDBMS, what are all the key characteristics associated with the big data, and what is in terms of architecture, what are all the ways by which you can categorize Hadoop, such as in terms of the storage, what is distributed database, and what are all the constituent components of its infrastructure architecture, master slave, what is name node, secondary name node, job tracker and data nodes, and how data has been stored, and what do you mean by HDFS, and what is MapReduce, and what are all various distributions of Hadoop. Okay. So if you have anything to be clarified, please let me know before winding up today's session.